Hello friends, today I am discussing about transportation problem, which is a very important and interesting topic in the OR. Here I covered the transportation problem and I would like to divide in three equal parts so that you can easily understand what is the meaning of transportation problem, how we have to find out its solution. Now first is the definition and meaning of the transportation problem. There is no any such definition available in any of the book where we have to define any transportation model, but with the help of example we can easily understand what is the meaning of this transportation model. Second one is the types. There are two types of transportation models, one is the balanced and second one is the unbalanced, and third one is the solution, which is the very important part for the transportation problem. The solution is divided into two parts. One is the initial feasible basic solution and second one is the optimal solution. Once we get the initial feasible basic solution, then we go for the optimal solution. We directly not use the optimal solution of any of the transportation problems. For the initial feasible solution, there is generally three types of methods. First one is the north-west corner method, second is the least cost method, third is the WAM method, full name is Vogel approximation method, and while go for the optimal, only one method is available, that is MODI method. The meaning of this MODI is the modified distribution methods. Now go for the first, that is the define or meaning of the transportation models. Any industry transport their goods from one place to another place, from one city to another city, even one country to another country, and they want to minimize their transportation cost so as least so that maximum profit is to be done. Now I take one example of car manufacturing industry. The three plants P1, P2 and P3 is located in different area of our city, and three different car stores S1, S2, S3 are located in three other different cities. Now for P1 is transport the car to store S1, 2 is the transportation cost of particular car which is to be transported from P1 plant to S1 store. Like this same to same way, the P1 plant deliver a car to S2 store and the transportation cost is 7, the third is 10. Like this we have to put all the initial values. These initial values show the total transportation cost for per plant to per store. Each and every plant having their definite capacity, which is known as the supply. So I simply put the values 10, 20, 40 is the supply of the plant P1, P2 and P3 respectively. Now the same way every warehouse is having their some certain types of demand which is to be written in terms of numerical value 10, 35 and 25. So this is cover your definition or your meaning of the transportation models. Now go for the second, that is type. While go for the types, there is two types. One is the balanced transportation problem and second one is the unbalanced transportation problem. While coming for the balanced transportation problems, if total supply is equal to the total demand, this is known as the balanced transportation problem. The meaning of this if we add 10, 20, 40, that is the supply of the plant is equal to 70, and if we add total demand of the three warehouses S1, S2, S3 10, 35, 25 respectively, this is around 70. So both the supply and the demand having equal value, so this is known as the balanced transportation problem. Suppose if I put some values around 30, then total is the 75. So this is known as the unbalanced transportation problem because supply is only 70 but your demand is around 75. So for this problem, first we have to be balance this unbalanced transportation problem, then proceed further. For balance this unbalanced transportation problem, we have incorporate one dummy row so that it should be balanced, right? Now third one is the solution of the transportation problems. While coming for the solution of the transportation problem, we have three types of methods. First one is the north-west corner method, second is the least cost method, and third last one is the WAM method. So I took one example from DS Hira book, which is the OR book. From this transportation model, we have just defined one transportation problem and solve with the help of north-west corner method. This north-west corner method means this is our north and this is west. So diagonal element we have to take first for our problem solving. So for this problem, this is a balanced transportation problem because the total supply is equal to total demand, that is 125 is equal to 125. So from this origin we have to take the north-west corner method. So first is the allocated cell value is 3. So we have to put the values in these 3 allocated cell value. Now here we have to concentrate on the minimum value. Supply is 20 but demand is 40. So we have to give the minimum value, that is the 20. So we put 20 in this block. Once we put the 20, then this supply is completely completed. This is 0 and the rest is around 20. Once we put the value of 20, then this row should be cancelled because there is no any further assignment is necessary to given in this row. Now again the same way we go for the northwest corner method. This is our origin. From this origin we have to identify this 2 is the northwest corner, so we have to put the values. Again minimum demand is 20 and maximum supply is 50, so we put minimum value, that is 20. While giving the 20, this 50 is should be around 30 and this column should be completely. Now again try the same way from this north corner method. Next identify cell value is 4. So minimum value is 30 and supply is also 30. So both values are same. So we put 30. Once we put the 30, then this column should be cut and this row should be cut. Then again go for this north origin and find the 2 is the minimum value. Total value is 55 demand, but the supply value is 30. So we put minimum value, that is 30. And this row should be complete cut. Now while giving the 30, this value should be 25 and the last one is the, while when we given the last value of any cell value, then we have more concentrate that both the columns and rows should be cut simultaneously. If that is happened, then we have to go in the right track. Now this is 25, we put 25 either in row or either in column. So this satisfies both the demand and supply, so this is cut simultaneously. Now this complete the problem. Now we find the initial basic feasible solution, multiply by those numbers, those cell values where we have to put some assignments, right? Then IBFS is equal to 20 into 3 plus 20 into 4, 20 into 2 plus 30 into 4 plus 30 into 2 plus 25 into 7, that is equal to 455. So total transportation cost for using the northwest corner method, we got 455. Now go for the second method, that is the LCM, least cost method. At the method is indicate, we have to use the least values of all the matrices. So first start or identify the least value, which is around 1 and 1. So we have to take any one of the, either we have to go for this or we have to go for this. Now I have to take this one. Again supply is 20 and demand is 55. So we put minimum value, that is 20. Once we have to given the 20 value, then this is remaining 35 is their demand, and this row is completely cut. Again find the least value, that is again 1, so put assignment in this one. Demand is 35, supply is 50, so we put minimum value, that is 35. So this is completely cut, and the remaining value, that is 15. Now again find the minimum least value, that is 2, so put the value in the 2. Supply is 15 but demand is 40, so we have to put the minimum value, that is 15, and cut this. Now the next minimum value is 3, so given the assignment in this 3 cell value, minimum value is demand is 25 and supply is 30, so we put minimum value, that is 25, and this is completely cut. Now we have two remaining two columns, two cell values 5 and 6. Minimum cell value is 5, so we put, given the assignment in this block, minimum cell value, minimum supply is 5 and minimum demand is 30, so we put minimum value, that is 5. This is completely cut, and the last one is the 6. Now the same way, the last column is very important because the columns and the row both are to be cut simultaneously with same values. So this is 25 and this is 25, means we have to go for in the right track, our problem is right. Now we put 25, now this complete the LCM method for transportation problem. Now the same way we have to find the IBFS solution. 20 multiplied by 1 plus 15 multiplied by 2 plus 35 multiplied by 1 plus 25 multiplied by 3 plus 5 multiplied by 5 and 25 multiplied by 6, that is 355 around. So total cost for the least cost method, total transportation cost will comes 355. Now the last one is the VAM method, that is Vogel approximation method. This is some suitable method for the transportation problems. Now for this method we have followed 3 steps. First step, we have take the difference of two least number in each and every columns and row. Then after taking the difference, we have to find out the maximum penalty of each and every columns. Then we have to give the assignment in those cell values which having least value. So let us start. Now start the penalties. Now first row, minimum value is 1, then next maximum value is 2, take the difference is 1. Now after this we have to find the IBFS solution of LCM method, that IBFS solution is equal to those cell values where we have given some values multiply by those number, that is 20 into 1 plus 35 into 1 plus 15 into 2 plus 25 into 3, 5 into 5 and then 25 into 6. After multiply, this will comes 335 is the total transportation cost while transferring the goods from one plant to warehouses. Now the third method is the VAM method, Vogel approximation method. For this method we have to follow 3 certain rules. First we identify each and every row the minimum value and then the next higher values. Take the difference of row columns. After taking the differences, we have to find out the maximum values of their differences. For their maximum value, we have to go for those row and column where having the least value. For example, now in the first row, values minimum value is 1, then next higher value is 2, take the difference is 1. Now second minimum value is 1, next higher value is 2, again difference is 1. Now third row, minimum value is 2, next higher value is 3, take the difference again 1. Minimum value is 4, next value is 6, difference is 2. Now this operation is for row. Now same procedure we have to follow for the columns. Now minimum value is 2, next higher value 3, difference is 1. Minimum value is 2, next value is 4, difference is 2. Minimum value is 1 and next is again 1. So we have to take this 2 and difference is 0. Now for the column operation is over, row operation is over. Now we have to take the maximum values of their differences. We have two values, either two, we have to go for this 2 or this 2. Any one we can select. Now I am selecting this 2 is first. Put the arrow mark so that you can easily identify. You have to take in this value is first. Now for this row we have to take the least value, that is the 4. So we put given their values in this cell value. So this is our first assignment value. This is 4. Again demand is 40, supply is 25. So we put minimum value, that is 25, and this will comes around 15. Once the supply is satisfied, then we cut this row. Then same procedure we have to follow. Again take difference, same 1, 1 and 1. Now go for columns 2 and 3, difference is 1. 2 and next value is 4, again difference is 2. 1 and 1, again difference is 0. Now we have to select the maximum value in the penalty, that is 2. So select this 2, put the arrow mark so that easily identify. We have to select this column. For this column we go for the minimum cell value, that is 2. So this is our value 2. Again same procedure, we have to find the demand is 30 but the supply is 20. So we put minimum value, that is 20. So write down 20. Once we put the 20, then demand will comes 10. So supply is to be satisfied for the first row. So cancel out this row. Then go for again same, take the difference. Now this second row 1 and 2, difference is 1. This row minimum value 2, next is 3, difference is 1. For the column difference is 1 and difference is 1. So we have to take any of the column or row because all the values are same to same. So I take these values, arrow mark. So we have to consider this column. In this column the minimum value is 4. So identify this. The value is 50 supply and the minimum value is 10. So we put the minimum value, that is 10. Now this is completely satisfied, so this column is completely completed. Now we have to only two cell values 1 and 2. So no need, we have to having two values, two columns 1 and 2. So again we have to take the difference 1 and 2, difference is 1. Now 2 and 3, difference is again 1. Take the difference 1 and 1. Again we have to take any of the 1. Now again take this value as a 1. Minimum value is the 2. Minimum demand is 15. and maximum is the 40. So we have to given the minimum value, that is 15. So write down 15 here. This completely cut, while 15 remaining around 25. And now we have only two cell values, 1 and 2. So we have to put the minimum value, that is 1. So first value is given 25 in this block. So this is completely cut, and the last one is the 30. Again we have to more concentrate. This is a value where we have to put the equal value of supply as well as demand. The supply having 30, out of 55, 25 we have to already put up, then minimum is the 30. So put these 30 values, and both the column and row will cut simultaneously. If that is happen, then our solution is optimal, and the optimal values is 20 multiplied by 2, 15 multiplied by 2, 10 multiplied by 4, 25 multiplied by 1, 25 multiplied by 4, and 30 multiplied by 2. This will comes 295. So total values is 295 for the WAM method, 455 from northwest corner method, and 335 from least cost method. So with the three method we can easily identify the maximum, the optimal values will comes from the WAM method. So this is 295 is the total optimum cost of the transportation problem. Okay, thank you.